guys thought about basic bugs that are common to both Solidity and Cairo? For example, reentrancy, access control bugs, etc. I'm going to need you guys to talk. Hello.
I'm sorry, what did you say?
Like, are you guys already familiar with regular security vulnerabilities that come onto Cairo and Solidity? For example, something like reentrancy or access control bugs.
Yes, I'm familiar for Solidity.
Okay. Is there anyone that is unfamiliar? Like, is there anyone that doesn't know what reentrancy is? Today, I'm going to be talking to you guys on anything and everything, Cairo. So if you have any question that you wanted to ask a previous tutor or something, and you couldn't get to ask them, I'm going to be here to answer it or anything. So don't be shy to talk. Anyway, regular bugs can also be found in bugs are found in other smart contract languages, can also be found in Cairo. And from my auditing experience, I noticed that it is actually quite easy to miss these regular bugs because we are already so familiar with them. Like, for example, something like an access control bug where you forget to set permissions. Like, people actually forget to set permissions, and you as an editor can miss it. So basically, what I'm saying is you should pay attention to all kind of bugs. Yeah, and yeah, have you guys been taught how? I'm sure you must have been taught what a felt is. A felt 252 is a felt is in Starknet. Let's see. Can you guys see my coding environment?
Yes.
Okay. So a felt is unbounded, right? So it is different from the U64, U32, whatever other unsigned integer types. So usually when you are dealing with Solidity, you know that if you are using like version 0.8 point something, you know that you no longer have to deal with overflow and underflow errors. And then when you move over to Starknet, you learn about things like U32, U64. Also, like we have, I think in Solidity is UINT32, then in Cairo it is U32. Okay, yeah. So you learn about all sorts of unsigned integers, but there's this value called a felt, which is actually unbounded. So whenever you're using a felt in storage, you must be careful to not make whatever you're storing overflow or underflow. Yeah. Okay. So that's and then I'm going to be talking about some other specific bugs, starting with this. Okay. So if you can see my coding environment, this is a simple contract. The contract is named sample. What it does is simple. it has a function, do nothing. And I saw in a previous class that you were taught that um, if you define a function like this and it has a snapshot to the contract state, it cannot be modified. And then when you have a reference, that's when you can set values, right? Yeah, I saw that in the previous class. So I'm here to tell you that that is not entirely correct. It is possible to create a function where a function that looks like it doesn't set any variable, but then you can use a low-level call later in the same function to set a variable. Yeah. So this function do nothing is supposed to look like it does nothing. Then set name is used to set the name storage variable, and then read name is used to read the value. So yeah, inside the do nothing function, we basically make a contract syscall. Yeah. Do you guys know what that is? Yeah. Hello. So a contract syscall is basically a low-level call that allows you to call any contract without having to call it straight dispatcher or whatever. Basically, you can call any contract, call any method. Like the method is the selector in this case. Let's call it method. Call any contract address, call any method, and then you put the raw call data. So what we do here is inside this do nothing function, we are going to call this same contract. Then we are going to call the set name function. There's this, the method is the selector for the set name function. Then we are going to set a name. The name here is going to be Shadi. And then we'll do a low-level call to this same address to set the name. But if you look at the function definition, it should look like you should not be able to set any variable. And then we can test it here we just declare and deploy the contract. And then originally, when you deploy the contract and you read the name, it should be empty. And then later you call do nothing, which should do nothing. But then when you check, you can check that after calling this do nothing function, it actually changes the name to Shade. I'm going to run the test here. Shit. So 1 second. Code has this way of fucking you up all the time. So when you need it. I ran this thing a second ago and it's worked. One thing I think. Okay, doing something wrong here. I'm not sure exactly what's happening. But basically, the idea is you can use a low-level call to update a function that looks like it cannot be updated. I'll update the example and probably send it out to you through David. Yeah. Um, yeah, currently on Starknet, we have a single sequencer. Yeah, and when you are creating a DeFi application, usually when you're working with Solidity, you assume that okay, you can front run because the the validators are decentralized. Yeah, so if you push front running is basically um you send a transaction to, let's say, buy, you have $20, you want to buy 20 stack, and then someone sees the transaction in the mempool, and then they submit a transaction with higher fees to go through your own first, so that when your transaction goes through, you actually get less dollar or something, so you can get maybe $15, and then they send a transaction after. Basically, they sandwich your transaction. It's something very popular. You can just maybe Google it. Um, Check out front running and sandwich attacks. But on Starknet, because we have a single sequencer, people generally do not consider sandwiching attacks. Yeah. But in future, Starknet sequencer is going to be decentralized, so it should actually be considered, and you should build your application as if you were building it on Ethereum. Yeah. Um, Next thing, okay. When you want to update a storage variable in Solidity, you you can do something like I'm not sure the exact way it works, but you can do something like address storage name is equal to name. No, um, okay. Let's say you have a storage variable called name in your Solidity contract. When you call it, when you want to read it, you can do something like storage name or something, and then you just get the value. And to change the value, you just do name is equal to new value. But it's different on Starknet because after you, if you read a value, so let's say I want to read the name now. Um, let's let name is equal to this, and then I want to update the name, and then I do name is equal to new name, and then I stop. This has not actually been saved in the Starknet smart contract, even though I think something like this would work in Solidity. Yeah, I'm certain. So in order for you to store it, people often forget to do self.name.write. Then you put the new name, basically. This won't work here because this can do this. Yeah, so basically you should remember to add this line. Yeah, Also, the sequencer doesn't actually handle execution failure. Like for example, I know in Solidity you can call a function. Let's say you call you have a contract, then in the contract you call arc20.transfer, and then while you after you call the transfer, you can maybe expect that there may be an error from the a panic from the contract that you are calling, and then you can handle the error in your own contract. So it might the transaction the execution might have failed in the other contract, like the other contract might have caused a panic, but then your own contract is able to handle the panic gracefully so that that panic doesn't shut down your own contract. So basically there are methods to do that in Starknet too, but currently it doesn't actually work. So if in my contract I made an ARC20 call and that ARC20 call panics, there is a like you can write code to actually handle the panic, but the code that you are writing will not work on Starknet mainnet. Yeah. So it's something that will be supported in future anyway. Like basically people just write the panic handling code so that a future version of Starknet can support it. But currently it's your panics are not handled gracefully. So the entire contract shuts down if there is any panic from anywhere. Yeah. Um, that's mostly it. Um, are you guys familiar with account contracts, like Starknet accounts?
I guess there's a message also on the chat. Maybe you want to check the message.
Yeah. Okay. If we can change read-only function values using low-level code, how can we ensure the security of the contract? Well, it's your job as an auditor to look into the contract and ensure that there is no low-level call inside supposedly read-only functions. Yeah, basically that's the only solution. Because if I deploy this contract to Starknet, it will actually read like and you view it up on Etherscan. Like you just I said Etherscan, StackScan. Let's see. So this is a sample contract. Then you go to the read and write part. Then these are the parts that you can read, right? It is actually going to show up here, even though it can manipulate the contract value. So I guess the only defense is to read the contract carefully. Yeah. If I deploy that contract now, and let's say this get version it was replaced with the do nothing function that I talked about earlier. From here, you won't actually be able to call it. You would have to use like you would be no, you won't be able to call it because it is going to fail when it tries to. Well, it could actually call it, but I actually don't know if it is going to fail from here. But it will fail. It is going to be a Starknet call. So no value is going to be modified. But if you call it from your if you're an advanced user and you call it from your terminal and you give the appropriate signature, it is actually going to do something. So yeah, it's a valid bug. Yeah. So what was I saying? Are you guys familiar with account contracts? No? Yes? Because I would really like you to look at this issue. After we are done today, just look at it and see if you can figure out what's going on there. If there's going to be a CTF tomorrow, something should definitely come from here. It's an interesting, I don't know if you guys know about accounts, so I don't want to talk to myself. Account contracts.
Ethan, Eniola, the questions.
I don't have questions because I missed a number of classes, so I'm just trying to, pick an idea here and there. Thank you.
Oh, Ethan. No, I'm not asking for questions. I'm like, they're asking about account. I just felt you guys are quiet, so that's why I'm calling out you guys' names. Yeah, but I'm sure I know you guys are following, but I just wanted to know questions you're asking.
Right. So, okay, if you guys are not familiar with account contracts, then this is not relevant. You can leave it out for now. So, these are basically the bugs that are found unique to Cairo, and I found them very interesting when auditing smart contracts. They are also like most of the bugs that I do find anyway are logical bugs. They are bugs that have to do with logic. So we can't really, I don't know if that is teachable. Yeah. And then it's not unique to Cairo. So you could also find those bugs in Solidity. So yeah, that's not part of the scope of this lesson. But I guess I'm done. If there's anything you want to ask me, you should ask about anything pertaining to Starknet. Okay. Doesn't mean a bad actor can inject low-level code into a smart contract with upgradable capabilities. I guess you could, yes, but I don't think that's unique to Starknet though. If you use proxy pattern in Solidity, you can also inject bad code, but then the readable functions in Solidity is there. I don't think there is. Okay, there's internal and external, so you can specify function visibility. Okay, well, when you have upgradable capabilities anyway, it's not until you inject low-level code, or you don't have to inject low-level code for you to make the smart contract vulnerable. You can literally do anything. So low-level code does not necessarily need to be associated with upgraded capabilities. Or how do I put this? Like once you have upgradable capabilities, you can inject any kind of bug. So yeah, how can you avoid it? Make the contract not upgradable. Like that's the only way. Yeah. Any other questions? You're welcome.
Okay, so yes, probably no more questions. Thank you, Mr. Credence. Yeah, this is quite just short, good, and precise. Awesome. I don't know if tomorrow we'll be having like a CTF you said, to be quite interesting also to have during the call, right? Maybe I don't know if it's during the call or how you intend that to also go, or if it's maybe a classwork or task for them to do during the class. I don't know how you intend, if that is visible. But yeah, I'll get to communicate with you after this, and then know the visibility of that, and then communicate with them. So yeah, thank you very much for the class today.
Yeah, you're welcome.
Yeah. So I think that will be all for now, guys. Thank you. So yeah, the recording will be also hopefully by tomorrow. Get to just edit and then have that on the channel. Thank you.
Thank you so much for your time.
Bye, guys.